Today we're going to talk about deriving the compound interest formula. In order to do that, we need to know some variables. So let's let I be the interest paid, A be the final amount, P be our principal starting amount, R be the annual percentage rate written as a decimal, N be the number of times compounded per year, and T be the time in years itself. We're given two things. We are given the interest paid is equal to the principal, our starting amount, times our percentage rate. We're also given that our final amount can also be found by the principal plus the interest paid. We're going to use all of this to derive the compound interest formula, which tells us the final amount after investing a principal with interest compounded n times per year over t years. Let's begin with the concept of the simple interest formula. If you invest a principal at P at an annual percentage rate, the interest earned in 1 year is I equals P times R. Let's give an example to see and understand. If P is $100 and our rate is 5% as a decimal 0.05, then the amount of interest earned is 100 times 0.05. Thus, the amount of interest earned in 1 year is $5. We can find the amount earned after 1 year by taking the principal plus the amount that we earned of $5, giving us $105. This then gives us the general form. The amount earned is the principal plus the principal times the rate. Of course, it would be easier to simplify by factoring the greatest common factor of P. This gives the amount after 1 year with simple interest, but compound interest is different because we know it builds on itself over multiple periods. Let's say we're compounding n times per year. In compound interest, interest is calculated multiple times per year. If interest is compounded n times per year, the interest rate per period is the rate divided by the number of times per year. For example, if our rate is 12% as a decimal 0.12 and we are compounding quarterly or 4 times per year, the per quarter rate is 0.02 divided by 4 or 0.03. For the first compounding period, we apply the interest rate R divided by N to the principal. Using the simple interest idea, the amount after one period is A sub 1, so our first period, is equal to the principal times 1 plus our rate of the rate divided by compounds per year. This is like our simple interest formula, but with the rate adjusted for one compounding period. In the second period, we're going to earn interest on the new amount, A sub 1. So we're going to take A sub 1, which equals P times 1 plus R divided by N, and apply that interest rate again. Now when we simplify, I see that there are two 1 plus R divided by N's, or P times 1 plus R divided by N squared. This shows the amount after two compounding periods, so we notice that there's a 2 reflected as the exponent, reflecting that 2 periods. If we did this again, in the third period, we would earn interest on the new amount, A sub 2. So we take A sub 2, which is equal to P times 1 plus R over N squared, and now apply the interest rate R over N again. Simplifying gives us our third period would be A sub 3 is P times 1 plus R over N cubed. We're starting to see a pattern here. Let's generalize. After each period, we're multiplying the previous amount by 1 plus R over N. After K periods, we see the pattern is A sub K is equal to P times 1 plus the rate over the number of times compounded per year to the power of K. The formula gives the amount after K compounding periods. Now we need to connect this to time in years. If interest is compounded n times per year, then over t years, the total amount of compounding periods is n times t. As an example, if we are compounding monthly, so n is 12, and the number of years we are compounding is 2, then there are 24 periods in which we're compounding. Thus, In general, K is equal to N times T. Let's replace K with N times T in our formula. We have now created the compound interest formula with starting with the simple interest, adjusting the multiple compounding periods per year, and generalizing over time. This formula lets us calculate the future value of an investment with compound interest.